Welcome back to another cooking show episode. Today we're gonna be making something special. Just like a throwback to first episode 2 years ago, we're gonna be making chai and pie, bruh. All right. So let's get started. I have measured out here 12 and a half ounces of flour, which is about 1.5 cups. And we're going to be putting this in our food processor. There we go. And next I have 2 tablespoons of sugar. It's brown sugar, that's just the sugar of my choice. I'm going to be putting that in. And 1 teaspoon of salt, make sure it's a teaspoon. And now we're just going to be pulsing. So, this is like wet sand now. And it took a while to blend. Actually, it was a combination between the blender, a hand mixer, and my hands. So that's fine. But now we're going to get, now we're going to add 6 to 8 ounces of ice water. The reason we add ice water is so the fats, the butter inside the dough doesn't actually melt, because this is going to be set for 2 hours. So here I have 6 to 8 ounces. It's about like half a cup to a cup, around there. So yeah, I'm just have this water. I'm just gonna slowly first. And slowly knead it by hand, just like in the good old days. Alright guys, so I've added some, a little bit of extra flour, it was not looking that flaky, and now I've patted it out into a disc. We're gonna let this rest for 2 hours in the fridge. So, just get some plastic wrap. Put some flour over it so it doesn't stick. Okay. Now we're gonna get some plastic wrap. Yeah, I'm gonna wrap this bad boy up. I'm just gonna mold it up again and kind of strip it in there. And we're gonna place it in the fridge. See you in 2 hours. Okay, so now that the dough for the pie is actually in the fridge, we can start prepping the apples. So here I've actually sliced and peeled the apples, green apples, Granny Smith apples. Get a good baking apple. And this is about 2.5 pounds, so about 6 to 7 like medium-ish to big apples. And add 3/4 cup of sugar. So that's 3/4. It's a lot of sugar, but it's apple pie, so it's healthy. Add 1 teaspoon of each ginger, cinnamon, allspice, and nutmeg powder. So I just have it all mixed up here right now. Yeah, it should be good. And add 2 tablespoons of flour. Now once you give this a mix, your apple should be done. Alright, the 2 hours is actually up now, so we got some dough for the pie. It's pretty, cold, obviously. It was in the fridge for 2 hours. And yeah, so let's just take it off the plastic wrap. Good, the plastic wrap didn't really stick. And we're just gonna split this dough into 2 equal pieces. My knife's not very sharp. Sorry about that. Okay? And we're gonna dust it with flour and pound it with the rolling pin. So we got a rolling pin here. Alright. Alright. Let's do the other side as well. Alright, I'm just gonna rock this for now. We're not using it right now. You actually wanna, roll this out 4 inches bigger than your, what you call, your pie plate or whatever. So, let's just get rolling. Yeah, so we're just gonna put this aside right now. Here's that. And now we can get this. This is the other half of our dough. Just like before, we're just gonna. Okay, and we're gonna roll this other half out. Alright, so I've cut out 10 layers, what they call lattices, I think, and 10 of them, 5 across and 5 horizontally. I've already put the apples into the pie, so yeah, we're just gonna be layering them. So here, let's start with number 1. Okay, now I've done the pie. I'm just gonna crimp it close. I have the oven preheating to 400 Fahrenheit, and you just put it in, and 30 to 45 minutes, you're done.
Okay, let's get into the actual chemistry behind this. So, I've actually calculated the amount of calories in 100 grams of apple pie, and in order to do this, I had to make a simple colorimeter. And I did this through getting a small can, a larger one, and I punctured the small can with 2 small holes and placed a rod through it, and poured in 300 milliliters of water, which turns out to be 3 grams of water, and got the temperature initial, which in this case was actually 22.1 degrees Celsius. And I placed a small can inside the larger can, but the rod is preventing it from actually falling into the larger can, so it doesn't completely go into the larger can. And I've actually lit some food. Sorry for the really rough sketch, but yeah, I've lit some food on fire, which in this case is our pie, and I've seen like the temperature actually go up. And once the food is completely done burning, I measure the temperature again, and I get the TF, which in this case was 23.2 degrees Celsius. And now here's the actual math behind this. So Q equals MC delta T, we can use this equation to actually calculate the amount of calories in this 100 grams of pie, and so we know that the specific heat capacity of water is actually 4.184 joules, and the water, I've actually cancelled it out because 1 calorie is equal to 4.184 joules. This is because the way they measure calories, the way a calorie is actually measured is the amount of heat needed to increase 1 gram of water by 1 degree Celsius at 1 atm, and this turns out to be 4.184 joules. So I just canceled it out from the start, because if I'm dividing by 4.184 and I'm already multiplying it, that just cancels it out, makes the math a little bit easier. And then I did 23.2 subtract 22.1, which I got 1.1, and multiplied that by the actual mass of the water, which gave me 330 joules. So the amount of heat released from the pie was actually 330 joules because it increased the temperature by 1.1 degrees Celsius. So that's how much energy was actually in the pie, and that's what makes this statement true. So we've actually figured out that 330 calories are in 100 grams of this apple pie. So I mean, it's not that healthy, but tastes good. Okay, another topic we can talk about is actually chemical kinetics and factors affecting the rate of the reaction. Here I have two pictures, a apple pie and a cup of tea, or chai, which is an Indian tea. And we're going to be talking about factors affecting it, like surface area, temperature, and actual chemical nature of a reactant. So the surface area matters a lot. For example, the surface area of sugar, granulated sugar, is higher than the surface area of a cube of sugar. The cube of sugar is going to take time to dissolve. And if you want, a cup of tea fast, you often use a granulated sugar because a cube of sugar is going to take too long to dissolve. This is because a higher surface area actually means a faster reaction because the frequency of collisions is increased, and a higher surface area equals more particles. So there's more actual sugar particles colliding with water particles, thus making the tea. Another topic you can talk about is actually temperature. Obviously, temperature matters. Okay, if you don't want to cook the pie at 40 minutes, you can if you don't want to wait for the pie to cook for 40 minutes, you can increase the temperature a little bit. A higher temperature actually means a higher kinetic energy, which actually means the speed of the particles is actually faster, which means that there's more particles actually colliding because they're all moving so fast that the actual frequency of the collisions increases, and particles with more energy from the heat, in this case, actually means more effective collisions. This is why temperature matters. This is why our food gets cooked. So we're not only we're getting more collisions, we're actually getting more effective collisions as well. And another thing is chemical nature. So here I didn't actually use yeast or anything like that for the pie. You often don't, but I guess you can. But for pizza, you use yeast in the dough. This actually increases the actual rate of the reaction. It decreases the rate of the reaction. It makes it slower. Because often when you use yeast, you want it to form gluten structure in the pie, and the pizza, and actually make it more fluffy and make it more textured, and get those leoparded bottom for the pizza, and make it crunchy. And you have to ferment that and actually wait for the gluten to relax when you're actually going at the dough and kneading it. So that actually drastically increases your time. So that's like making like a 30-minute pizza compared to like a 4-day pizza, because you have to wait for the actual gluten to set and the yeast to fill up. These are three factors actually affecting the rate of the reaction: temperature, surface area, and chemical nature.